Good evening, everyone. Good evening. Okay, na? Okay. Good evening, everyone. It's my honor to introduce Dr. Digvijay S. Pawar, an esteemed associate professor in the Department of Civil Engineering at the Indian Institute of Technology, Hyderabad. Dr. Pawar earned his PhD in Transportation System Engineering from IIT Bombay in 2015. Following in master's in the same field, bachelor's degree in civil engineering from Walchand College of Engineering, Sangli in 2009. Dr. Power's research focuses on intelligent transportation systems, traffic safety and accidental analysis, geometric design, naturalistic driving studies, and human factors. His notable contributions including developing ITS technologies to enhance driver and pedestrian safety vehicle at uncontrolled intersections and establishing a test bed at IIT Hyderabad for autonomous vehicle systems research. His work has been recognized with several honors, including the Networking Grant Award from Academy of Mechanical Sciences, UK, the CODATU 2017 Best PhD Thesis Award on Urban Mobility in Developing Countries, and the Excellence in Thesis Work Award from IIT Bombay from 2014 to 16. He also served as Young Conference Chair for the World Conference on Transportation Research in 2019. Dr. Power is an active member of various professional organizations, including the Transportation Research Board, USA, the Institute of Transport India, and the Indian Roads Congress IRC. He has also held key administrative roles at IIT Hyderabad, such as faculty in charge of the National Cadet Corps and the National Service Scheme (NSS). Please join me in welcoming Dr. Digvijay S. Pawar for his valuable session. Over to you, sir. Let me wait రావట్లేదా? ఏమి ఆయన కాల్ ఎండింగ్లో పోయిద్దంటవా? ఏంది ఇది?
तो कुठे चाललेस? लॉक काढ म्हणलं काढ. कुठे चालल्यास? काढ लॉक काढ. कुठे चालल्यास ते सांग आधी. लॉक काढ. कुठे चालल्यास? ड्रामा करू नकोस आता. कुठे चालल्यास तू? अभि मग काय करायचं नाही. लॉक काढ. आता गाडी थांबली ना तुझी. तुझ्या चालत्या गाडीत काय
Yeah, can you hear me? Mr. Ganesh, can you hear me?
Yes, sir. We can hear you, sir.
Okay, so what I'm doing is I've connected myself through mobile phone speaker. Okay.
Okay, sir. It's loud and
And
clear, sir. Very well, sir. The sound is good.
okay, great, great. So thank you. I mean, thank you so much for having me over here. Thank you for the introduction as well. So all of you, good evening. Good evening to everyone, all the participants. Thank you for joining this today's session. May I know if my screen is visible or I've not shared it?
The screen is not visible, sir.
Okay.
Yes, sir. We can see your screen, sir.
But you might be okay now. You might be seeing two screens. Okay, got it.
Yes, yes, sir. Thank you, sir.
Just a minute. How about now? Is it perfect?
Yes, sir. Perfect, sir.
Great, all of you. Thank you so much. Shall I get started? Yeah. Shall I begin?
Yes, sir. You can, sir. Thank you.
Yeah, thank you. Thank you so much. Once again, good evening, everyone. So today's topic is more on advanced technologies, especially with respect to the vehicles. So I'll be presenting on autonomous vehicles in Indian context, where exactly we stand when you talk about different levels of autonomous vehicles. Okay, but before I move on, I just want to give you a overall context of the smart city. So when you talk about smart cities, and especially in context of transportation, it is more about how well the transportation system is developed and connected to people, right? All of you. So it's all about integration of different transportation systems. For example, integration of public transportation with the last mile and first mile connectivity. How well people can get access to the transportation system that is being developed. So today, I think many of us Google to find quick answers, right? And when Googling this specific question, one of the first results from Wikipedia currently summarizes a smart city as a urban area that uses different types of electronic data collection sensors to supply information which is used to manage assets and the resources efficiently. Okay, so there are several such definitions when it comes to smart city. Okay, um, people talk about developed urban area that creates a sustainable economic development and high quality of life by excelling the multiple key areas: economy, mobility, environment, people, living, and government. Right. So there are several such definitions which exists. Okay. So here the intent is to use the technologies to provide intelligent response to the needs of the city. Right, all of you. So when you talk about smart transportation as such, if you see, uh, the urban multimodal systems for high density megacities lies at the center. And if you look at the other contributing factors to the smart transportation, it includes the planning, smart sensing, smart performance, travel behavior, smart travel behavior, and then technologies and urban infrastructure. So everything is actually interrelated. Okay, so of course it starts from urban planning to system design, and then the outcomes and impacts. Now there are several such areas where we talk about key innovations in mobility. To be specific, in the industry of mobility, so we are talking about autonomous vehicles, we are talking about connected cars, big data, shared mobility, augmented reality, right? Lightweight materials, in vehicle services, mobility as a service, and so on. So I think some of you are aware of autonomous vehicles, right? All of you, driverless cars, where we talk about different levels of autonomy. Hmm? So level zero, I mean SAE, Society of Automotive Engineers, has classified the level of autonomy into six levels, I would say that way. So level 0 begins with like no automation at all. Then you have level 1, which has ADAS level 1, ADAS level 2, and then you have level 3, which is conditional automation, level 4, which is close to full automation, and then level 5 is full automation. So these are the different levels of autonomous vehicles that we have. Then we talk about connected cars, right? Where we talk about vehicle to vehicle communication, vehicle to infrastructure communication, vehicle to everything, that is V2X, right, all of you? So here, what we are trying to do is, I think you all are aware of the fact that uh, close to 80 to 85% of crashes in Indian context are actually attributed to human error. That means the driver, the humans, who are responsible for the crashes. Even drivers are responsible. 80 to 85% of crashes are attributed to error by humans. Uh, so that means these crashes can be avoided, right? So these kind of accidents can be avoided if we try to assist the drivers or we try to replace the driver. Now, to what extent we can replace the driver, okay, completely from the driving seat is something questionable, especially when it comes to Indian context. I mean, that is something that is debatable, that is something which can be taken up for discussions and so on. So can we have a technology where where the driver is not able to take a right decision? We can assist the drivers in taking the decision. Let's say, a very good example would be in the north part of India, where you have these freeways or expressways, and whenever there's a fog, especially during early mornings, the driver is not able to see the vehicle ahead, right? So then, can there be a technology which can assist the drivers to recognize or to find the vehicle ahead of it? Okay, so this will help you in many ways to understand or to avoid the front end crashes. Okay, then it can be vehicle to infrastructure communication. It can be vehicle to everything. What it means is even vehicle to pedestrian communication. So whenever you are commuting at an intersection and let's say you are not able to see the pedestrian because pedestrian is occluded behind a truck, but can I get this information in advance? Okay, can I understand in advance that yes, vehicle is actually in a possible conflicting course with the pedestrian which is about to come onto the road? Is it possible? Yes, it's possible. Can pedestrian get to know about the possible collision with other vehicles? Yes, it is possible. I can I have a watch, a wristwatch, which will actually is smart in nature, and it's connected to the surrounding, connected to the users, other users, where he or she is sharing the space. So the moment is somebody is in my collision path. Um, can I get a alerts? Can I get a vibration stating that, oh, you need to be alert, right? So likewise, a lot of technological developments are happening in the mobility sector or in the transportation sector as such. Okay, we are talking about shared mobility, right? Which we all know that. Okay, so the people are looking into car sharing, carpooling, ride sharing, bike sharing, scooter sharing, and so on. And then about augmented reality, that is holographic navigation system presents warning alerts and safety aids. So it's so the difference between the augmented reality and virtual reality, right, all of you? So I don't have to get into those details, but you can augment, you can augment the current infrastructure into an infrastructure that you are developing and try to see how the users are responding to that new infrastructure. Now people are talking about lightweight materials when it comes to vehicles. In vehicle services, people are talking about mobility as a service. It's a very interesting concept where it offers a consumer the possibility of accessing a variety of vehicles by using the same digital platform, right? Same digital platform. For example, very simple example, today we use Google Maps, right? And in the Google Maps you choose an option like, let's say, I want to travel by car, and therefore by car it shows you the shortest path, either based upon time or based upon distance. Okay, it has all those algorithms which takes into consideration the previous historical data and gives you the details about the shortest path and even the existing data. So But can I have a multiple options where not only by car, if you use any other mode of transportation, these are the possible options you have. You just go by bicycle at this location, you take a public transportation, you take a some other mode for last mile connectivity. Can I have all those options? That is something currently missing in Indian context, and this is quite common in other countries, especially the developed countries, where it gives you all possible options that you can actually uh, experience or commute with, right? So this is with respect to the innovation areas in the mobility industry, right, all of you? So now there are large scale trends in transportation technologies. People are talking about technologies related to vehicles, technology related to engine, material, infrastructure and operating technologies, emerging new mobility products and services. That means there is a huge scope. So if you look at the overall development, the overall progress in the transportation sector, it cannot be simply based on a one specific entity. What it means is that you cannot just have safe vehicles, but compromise on the road infrastructure or compromise on educational aspects, compromise on enforcement aspects. No, you need to focus. It has to be a holistic approach when you talk about safety aspects, right? So uh, the emphasis has been on different aspects when it comes to transportation technologies, right? We are talking about lightweight material, but at the same time, we are talking about, maximum strength for which the vehicle can be built. Okay, so certain sections of the vehicles are actually made up of ultra high strength steel. Some of them are extra high strength steel, very high strength steel, and so on. So because that you have to work on the cost aspect as well, right? At the same time, the cost of the vehicle has to be low. So a lot of progress has been happening, in this specific sector. Again, we are talking about passive safety measures. We're talking about active safety measures, right, all of you? So when you talk about passive safety measures, you talk about the seat belts, you talk about airbags, huh? You talk about the chassis, how well the vehicle can take the impact. And then you have active safety systems within the vehicle, which can actually help the drivers to avoid the crashes itself. So when you talk about passive safety systems, it is to do with, if the crash happens, how well I can protect my users, how well I can protect my passengers who are sitting in the car, right? And then at the same time, you have active safety measures. These are the measures to avoid the crashes. The crash itself can be avoidable, okay, by alerting the driver in advance, okay, by giving warning to the driver, stating that, okay, there is a lane departure happening, you please remain in the lane. So there are several, like for example, ADAS systems or the autonomous vehicles that we are talking about. These are all active safety features where the vehicle actually intervenes. The vehicle uh, takes care of the driver proactively, okay, or the passengers proactively. So when you talk about the trends in vehicle technology, okay, so although an integration into transport system would already be technically feasible, the non-technical issues, okay, specifically to do with the consumer's confidence, to do with the legal aspects, uh, there are difficulties involved at different levels, right? And these are unpredictable. We have unpredictable traffic challenges, okay, conditions, and these are the major constraint the transport industry is currently facing. So, if you all look at the autonomous and connected vehicle systems, which is the emerging trend right now on a large scale. Why I'm showing you this specific timeline is we actually uh, began with just a car which was so simple, and then we are talking about cars which are so sophisticated. It has economics taken into consideration, safety features taken into consideration. So previously your role was to commute from one location to another location. Yes, now also it's the major intention. However, how safe I can do that commute, that is something which is questionable in the current environment. So although an integration into transport system would already be technical feasible, okay, I have said this that non-technical issues, especially to do with the consumer's confidence and legal aspects, that is something really challenging for OEMs. Whether people can trust this system, can people trust this system? Can people afford this system? Okay, so that are some of the challenges, especially in Indian context. People think about the cost. So no sooner you add this kind of luxury in a car, you know the cost is going to shoot up. So can I afford this vehicle? Is it possible? Do I compromise on the number of airbags? Do I compromise on certain warning systems the vehicle has, and so on? Okay, so there are several such challenges. I think all of us have come across, but let me take you through the brief history, okay, in detail, actually. So, if you look in 1886, the first car was invented. Um, uh, 1908, the Ford produced Model T, okay. So, the electric ignition came in 1911, okay. So, just to give you a reference, the cigarette lighters were introduced in 1921. So, and then we had this coil spring suspension in 1934, car radios in 1930. Likewise, the car keys came in 1949 and so on. Then power steering in 1959, 1951. So you can look at the way this has been progressing, and when these things have come in Indian context. Okay. So this is not about Indian context, of course. And then the seat belts were introduced in 1959. So Volvo actually invented the seat belt and gave it to other car makers for free to save lives around the world. They would have patented this technology, but they did not do this because the intention was to save the lives on the road. Okay, and of course, then we talk about, just a minute, all of you. Some call is there. I'm just canceling it. Okay. Then this electric windows came into picture, intermittent window shield wipers in 1969, digital dashboard displays in 1974. Okay, all these things, if you see in Indian context, they would have been delayed by 10 to 15 years because, not everyone can afford, and therefore you may not have seen that. There were vehicles which were high end, but maybe the common people could not experience it. Okay, and then airbags came in 1988. Okay, and originally they were just for drivers, but today we are surrounded by airbags to protect all the passengers. Right? We are talking about four airbags, six airbags. 1996, we started talking about connected cars. So what it means is actually your car can use your mobile phone automatically, can do emergency calls. Now we are talking about, can cars speak to each other? What it means is they are connected to each other. And to give a very classic example, um, in order to avoid the delay in the responses, okay. So, for example, if the front vehicle applies the brake, it will take some time for me to apply the brake because there is a response time involved in that, right, all of you? So it will get delayed. So if my response is delayed, okay, there are high chances that there might be a crash. So how can I avoid that uh, delay? It is possible if my cars are speaking to each other, if my cars are connected to each other. So the lead vehicle applies the brake sooner, no sooner, I mean, the vehicle behind it gets to know about what is happening ahead, and it also responds accordingly, right? So, then in 2000, GPS satellite navigation system was introduced. Okay, the Toyota Prius was the first hybrid car powered by petrol and electric energy, which came in 2000, right? Hands-free Bluetooth in 2001, reversing cameras to 2002, and then automatic parking system, driver assist features. I've been there in 2010, right? Since 2010. So this includes driver safety features like traffic alerts, lane departure warning, and so on. So these are certain warning systems that already the vehicles have. Okay, so then we have 2014, this Tesla's autopilot. Okay, Elon Musk autopilot technology came. to steer the car and even change the lanes on the motorway. So that was a successful model. Today also, this model exists and available for sale. Of course, it has even I would say a crash record, which states that it has a maximum number of crashes. Then 2014, 4G Wi-Fi hotspot came into picture. 2020, self-driving cars. We are talking about cars which can drive on their own. Now, for some of you, it would be surprising, to understand that is it really possible to have this kind of vehicles on Indian roads? Because you see the traffic on our roads, it's mixed in nature, quite heterogeneous. Um, People don't respect the priorities, uh, undisciplined, lanes are not being maintained. There are a lot of issues in Indian context, and of course we are trying to address those issues and how exactly this can be done. Okay, so believe me, all this is possible because if you look at the way the mobile phone has been evolved. I hope some of you actually could recall those Nokia 1100 or Nokia 3210, almost, I would say. Uh, yeah, I think 20 years back. Okay. People used to have that phone. And now we are talking about mobile phones which are smart in nature, touchscreen phones. In fact, when the touchscreen phone was launched, when it came, people were reluctant to use it. People wanted this keypad. People wanted this QWERTY keypad phones because they were more comfortable with that. And now, if I ask you to shift to those mobile phones, you will feel like, oh no, 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 you can't do it because it's not advanced. You're not fast. So look at which the adoption of the technology, the way which the adoption of technology is happening. So same applies with vehicles as well. Just look at the vehicles which we had 10 to 15 years back and the kind of vehicles that we are owning. Even a 15 lakhs vehicle is now coming with the ADAS features, right? All of you. So that means there are systems which are getting developed. The cars are becoming more sophisticated. Over the time, they are becoming cheaper as well. The technology is becoming cheaper. So there's no doubt with respect to the improvement in the technology, and people are trying to opt for the technology. Okay, so no doubt that autonomous vehicles will come on Indian roads. Yes, they will come one day. It is just that how do we handle the situation, right? So let me give you some other classic examples of the way the technology has been adopted. This is specific to US, all of you. Okay, of course this data is available till only 2005. I'm presenting something which is 20 years old, but very interesting. The way the telephones were actually adopted by people. It's a consumption rate. Okay, see, it's very interesting, all of you. If I could use a pen and I can show you the cell phone, right? Look at the way the cell phones have actually being consumption has been spread. Look at this graph, right? Within the shortest time, the spread has been so high. Look at the way the computers were actually being adopted by the people, and the slowest rate would be something like telephones. Okay, slowly, 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 because cell phones came into picture, the people started shifting towards the cell phone. Then there are cloth washers. Okay, look at it, how it is happening. But especially when it comes up to the technology, you talk about computers, you talk about internet, you talk about cell phone. Look at the adoption rate. Huh? So the consumption spreads faster today. That's what actually I want to highlight. Okay. So there are of course five levels of I would say six levels of driving automation. Okay, because SAE, the Society of Automotive Engineers, states that six levels of driving automation. Okay, level zero I did not state it as an automation, and that's the reason why I mentioned five levels. But you can actually mention it as six levels of driving automation. So level zero means no automation. That's the reason why I mentioned five levels. Okay. So where the steering and acceleration, deceleration is taken by care by driver itself, monitoring of driving environment by driver itself, fallback when automation fails, driver itself. Okay. But when it comes to the level one and level two, you can see there is a slight change over here. Okay. So it's steering and the acceleration, deceleration. Okay, you have some role to play by the driver and some role to play by an automated system. And then monitoring of driving environment is fully done by the driver. The fallback when automation fails, of course, it's all taken care by driver. Okay, and it does have some driving modes. For example, the ADAS. You talk about advanced drivers assistance systems. Okay, this ADAS system specifically, when you talk about it includes, let's say, a lane departure warning system, lane assist system, forward collision warning system, pedestrian collision warning system, blind spot warning systems. So these are the systems which are actually meant to assist the drivers, not to take complete control on the vehicle. It is more of an assistance to the driver. Then you have a partial automation. For example, the Tesla's autopilot vehicle. It's a level 2 vehicle which is already available in the market for uh, people to buy or to own it, right? So where you talk about acceleration, steering, acceleration, deceleration, fully taken control by the automated system. However, the driver has to take care of the system when the driving environment changes. Okay, the fallback. That means the vehicle will actually tell you to take control on it whenever it is not able to decide. You know, the system that it has to apply. Then we have conditional automation, where the steering and acceleration, deceleration is taken care by automated system, whereas monitoring of the driving environment is also done by the automated system. So the vehicle on go tries to understand what type of environment it is facing, and accordingly, it tries to be like a human, taking the decisions on go. You apply the brakes, you accelerate, you decelerate, you change the lanes, right? You stop, go, respect the priorities, and so on. However, there will be some scenarios where the driver or the vehicle is not able to take the right decision, and then of course in the fallback condition driver has to take care of it. Whereas the level 4 and level 5 is like a full automation. Okay. So what I mean is the level 5 is somewhere your vehicle will not have acceleration, brake, or clutch paddles. It will not have a steering. It may have, a dashboard where you can come and actually give some voice commands, and then vehicle takes those commands and actually starts the journey. Whereas in high automation, it will have certain modes, okay, where you have to take the control. And therefore, in certain situation, a very complex situation where vehicle is not able to take the decision, okay, it will ask you to take the control. So some driving modes it will definitely have. Okay, so these are the different levels of driving automation. Okay, so you consider it as a 6 levels of driving automation rather than saying it as a 5. Okay, I myself I mentioned sometimes 5. The reason being is level 0 is something which does not fall in automation at all. Okay, so let me give an example of the uh, Tesla's autopilot mode. You can see here. You can look how exactly the vehicle is actually trying to uh, make the journey. Okay, and I also want you people to observe the speeds. Okay, so those digits which are changing. Right now it is 75. It's miles per hour. Okay, it miles per hour, which means it is close to 120 kilometer per hour. Okay, 120 kilometer per hour. It is flying at that. It is changing the lanes. Okay, see how exactly it is changing the lanes. I think you people are seeing the video possibly slightly in slow motion. However, I hope you can gauge that the vehicle is able to take the decisions at the intersection, getting off the ramp, perhaps off the ramp, getting onto the ramp, maintaining the free flow speed. Okay, it is respecting the priorities, respecting the lane markings. It has respected the stop sign now. Right, all of you. So yes, I mean technology is there, but how do we adopt this technology for Indian context is something really challenging. But let me take you to the initial phase of development of autonomous vehicles. I'm not sure how many of you recall the possibly the first crash that was being witnessed while testing the autonomous vehicle, and that was the self-driving Uber. Okay, so when this testing was happening, uh, the pedestrian, I mean, there was a woman, okay, who was actually on the bicycle, and it was a Sunday night. Okay, and there was an autonomous car operated by Uber, which was going under testing. Although with an emergency backup driver behind the wheel, it struck and killed a woman on a street. This happened in Tempe, Aris, okay? And it is believed to be the first pedestrian death associated with the self-driving technology, okay? And the company quickly even suspended the testing in Tempe, as well as in Petersburg, San Francisco, and Toronto. So if you see, this is the autonomous vehicle, okay, which was actually flying with a backup driver as well. And then there was a lady, a woman, possibly, more than 60, 70 years, along with a bicycle. She was carrying her bicycle and she was trying to cross here. And this was the point where this vehicle struck her. Okay. I'll show you how exactly it happened. So maybe you can experience this as well. So, this is the vehicle. You can see here now, suddenly when women, you can see this is the point exactly where the vehicle stuck to the pedestrian. This is the actual, the backup driver, okay, uh, behind the wheel, okay. And these are his expressions which were caught, okay. So I'm playing this video again. So this is the vehicle which is flying, and suddenly it sees, it comes across this woman who was crossing the road. It struck her, and this is the backup driver sitting who was engaged in some activity. Possibly he was on his phone, and suddenly this event happened. Okay, so these are the challenges, of course, when you're testing on the roads, especially the public roads. And I'm slowly I'm bringing you something, bringing you to something which we have done at IIT Hyderabad. Okay, so uh, can you guess? Can someone guess? What are the most common types of crashes which are uh, you know witnessed by autonomous vehicles? Any guesses? So what I mean is, we know the different types of crashes. Okay, like let's say head-on crash, rear end crash, side end, side swipe. So these are different types of crashes that we know. Okay. So in case of autonomous vehicle, in your understanding, okay, let it be wrong. All of you, don't worry. What are those type of crashes which are often seen? You know that the vehicle is coming across. So you can text, okay, or you can even let it be wrong. I'm just asking you, you to guess, okay, what kind of a crash vehicle might uh, witness, especially an autonomous vehicle, has witnessed already. There's some statistics, and I want to understand from you people that okay, these are the type of crashes, those are possible. Any guesses? Any messages? You can even unmute yourself and let me know if you have any guess. So if you look at this specific slide, Google's report of AV accidents account for 80% of the total. This is old statistics I'm talking about, data which is reported from 2014 to 2017. Okay. So of course this disparity is due to a much larger effort in terms of fleet size and the mileage that is being traveled. Okay. Uh, by the Google. Okay. So this is the visual reconstruction of the AV accidents, and if you see these slides, all of you, you can observe that they have made very interesting graphicals about the AV being involved in crash with other vehicles, and they have shown rear end crash, side end crash, and so on. So different types of crashes are actually shown over here. Okay, and if you see these cross points are actually the points of collision. Okay, these are all points of collision. You can see rear end crash here, rear end crash, side swipe. Okay, and interestingly, the rear end crashes are the maximum number of crashes recorded with respect to autonomous vehicles. And the reason being is, there are instances where the vehicle is not able to understand or vehicle is not able to decide what needs to be done. And in that case, the vehicle brakes suddenly. The moment you brake suddenly, there are high chances that the following vehicles would actually end up crashing on autonomous vehicle. And that's the reason why the maximum number of crashes, 62% of crashes were attributed to rear damage, okay, 23% to side damage, and 15% to front damage. That means the autonomous vehicle has collided with another vehicle in front. So that's the front damage for the autonomous vehicle. So you're talking about the damage with respect to vehicle one, that is the autonomous vehicle, and vehicle two, which is conventional vehicle. Okay, and obviously when you say this is the contribution with respect to the rear damage, there will be obviously the front damage taking lion's share. Okay. So, yes, of course, the autonomous transportation has um, advantages. Okay, it has certain edge over the conventional transportation, be it reducing the emissions, improved road safety, increased traffic efficiency, fuel consumption. Okay, reliability of transportation system, and so on. Okay, um, that's what the reason what the industry has been quoting, which I have also discussed about the level of automation, what level 0 stands and then what level 5 stands. But at IIT Hyderabad, let me now tell you what are our efforts, because I just don't want to give you a presentation about the technologies associated with the vehicles that exist elsewhere, but what we are doing. So at IIT Hyderabad, we have established a facility called as TIHAN, that is Technology Innovation Hub for Autonomous Navigation, okay, where we do testing for connected autonomous vehicles. Okay, here we offer early stage testing and deployment, funding for wide range of mobility research, data collection, commitment to education and outreach. So this specific facility was actually inaugurated in 2022. Okay, and it was inaugurated by Dr. Jitendra Singh, Honorable Minister of State, Independent Charge, Science and Technology and Earth Science, Government of India. Okay, so if you want to go through the inauguration video, you can see this video. We have our own autonomous vehicle flying within the campus, but before I move on to that, I want to show you the facility that we have developed. So this is the connected autonomous vehicle test bed. Okay, it's a full-scale outdoor laboratory which simulates the broad range of complexities the vehicles encounter in urban and suburban environments. Okay, it is spread across 12,000 square meter area. Okay, now it is expanded to almost 22,000 square meter of area. Control network, both wireless and Ethernet and V2X communication throughout the facility, and 5G connectivity is facilitated. So it's an open testing environment, the way we have labs, all of you, the way we have, laboratories, and in our institute, our laboratory is this specific test bed that we have developed. Okay. So what we do with this, we have planned emulation of the mixed traffic environment where we do police control intersection, all these things, pedestrian control intersection, pedestrian crossing at signalized intersection, cattle crossing, mixed traffic in general. You can emulate all these scenarios, traffic control measures, vehicle to vehicle communication, vehicle to infrastructure communication. We also have our own dummies, and these dummies are costing worth crores, because the platform on which these dummies actually fly, it's so costly because the way it functions is something totally different from the conventional platforms that you see. So um, it's an interesting, I would say, facility that we have developed at IIT Hyderabad. In fact, I would invite you all to visit IIT Hyderabad and witness this facility. I'll show you, of course, the video. So this is the sketch of the facility that we have at IIT Hyderabad. And these are all surveillance systems that exist. We have 2D radars, 3D radars, camera systems, cameras, point the PTZ cameras are deployed, which are pan, tilt, and zoom cameras. Okay, bullet cameras, and so on. So In general, before I conclude, I just want to show you certain aspects about the testbed that we have developed. Okay. So you can actually search on Google on the YouTube, Tihan IIT Hyderabad. Okay, I'm just taking you all directly over here. Okay, so we also have this autonomous campus shuttle. Okay, which is flying uh, on our campus roads. Okay, so this is the shuttle. This is the test bed that you see, all of you. So this is the testing of the actual vehicle. So it stops at the bus stop. So we have concrete roads, we have normal roads. So this is the mechanical integration facility behind, okay, the building that you see. It's a mechanical integration facility that has been developed at IIT Hyderabad, where we integrate our vehicles with the technology. Okay, and this is the test facility, the test track that you have seen now. And within the campus, we actually have our own autonomous vehicle, which is which takes the students from one point to another point. Okay. Premier Institute of Science and Technology, established in 2008, consistently ranked. So this is our campus, the IIT Hyderabad campus, all of you. These are the different buildings that academic buildings, technology research park, innovation hub, convention center. Okay. This is the test facility. That's what I wanted to show you. Okay, this is the test facility where we do all kind of testings, especially with respect to autonomous vehicles. And then, yes, this is the view from inside, specifically mechanical integration facility. Professor Rajlakshmi, who is the professor in electrical engineering department, she is currently heading this project. She is the director of Tihan. And this is one of our autonomous shuttle, okay, which actually is flying within the campus from hostel area to the main gate. In fact, we make 8 trips in a day. Okay, morning 4 trips and in the afternoon and evening 4 trips. So whenever you come to our campus, you can actually witness. Of course, this is moving at very low pace, which is 15 kilometer per hour, but you would enjoy the ride. So this is currently operational in Indian context. So today I have talked about the trends in vehicle technologies, and I have a talk tomorrow as well, which is scheduled for 1 hour. Okay. So tomorrow I'm going to talk about trends in infrastructure and operating technologies. Okay. So with this, we will stop here, all of you, and we will keep 4 to 5 minutes for discussion. Okay. Thank you so much.
Thank you for the valuable session, sir. Now I request all the participants, please unmute yourself for the query session.
Hello, sir. Hello, Pawar, sir. Hello. Hello. Hello.
Yes, kindly be on the
I
line, sir.
can hear you. I can hear you. I can hear you.
Hello, sir.
Yes, please go ahead. Please go ahead.
Sir, you are saying that about the radial roads or whatever it may be. Sir, if there is suddenly any changes on road, can it be identified, sir?
So as of now, like when you say changes on the road, may I know what is that coming in your mind? What kind of changes? Because
Sir,
road is an infrastructure, it's an entity
in
which
the
is
road
supposed to be
infrastructure.
constant.
Hmm.
Yeah, tell me.
So suddenly there is any blocking roads or suddenly there is a chance of exchange of roads like that. What happened for this type of the automation cars, sir?
Yes, yes, yes. Let's say suddenly there is some work related to manhole, okay, on the roadway, and
Mm.
suddenly it's being blocked. The road is blocked. Let's say that way, and the traffic is in mid and is diverted. Okay,
All right.
so if your system,
Mm.
like for example, let me tell you, in the MIT US have designed a system which is called as MapLight. What it means is like the vehicle can understand the road infrastructure on go and can take the decision. But as of now, in our case, no, it is vehicle will not be in position to take the decision. Okay, even in case of level 2 vehicles also, if a particular vehicle is not being trained for a specific use cases, it will ask driver to take over,
Okay.
and then the driver has to maneuver that particular scenario.
Yeah.
Because please understand, you can train the vehicles for various conditions, but understand that every condition is unique in itself.
Yeah.
Yeah. So those are the challenges that we face, and that's the reason why, replacing humans completely is very difficult. I mean, there will be situations where the engagement with respect to human has to remain. Yeah.
Thank you, sir.
Any other questions? If you want more information, I'm not sure how many participants we have here. All of you, I also run, a channel called as traffic bytes underscore bytes. If in case, I'm not sure if you people are active on Instagram, but I run a channel on traffic safety where I talk about safety aspects the users should be aware of when you are actually on the road. I try to cover why certain things are designed scientifically. So So that's the channel which I have, which is termed as traffic bytes, TRAFFIC_bytes. I have actually texted this in the group. Okay, all of you can see that, or else you can simply scan the QR code. I can just give a QR code to you all. But I think I have mentioned here, I guess that should be enough for you. Any questions, any information that you need? So you can actually, look at the videos and certain things that we have been doing at IIT Hyderabad. I also run very interesting quizzes on this particular channel. Okay. If you feel like, okay, you want to ask your students to, face some quiz, they can just open this specific quiz. So I can share my screen over here for your information. This is the channel that I run. Okay, and you can see it's a traffic bytes. Okay, so where I actually display the information about what we have been doing, and then suppose if you're interested to take up the quiz, you can just answer here directly, and these answers are not recorded. They don't go anywhere. It is just for your information. So like this, you can ask your students to take the quiz related to transportation, and I try to even clarify why that specific answer is like that. These are the quizzes that we have designed for different users. Okay, so you can take the quiz and so on. Yeah. So with this, I think all of you, I'll stop here. Thank you so much.
So we have a question in the chat box, sir. Can I read it?
Yeah, I will just look at it. Just a minute.
Okay, sir.
Can you explain the ethical dilemmas around decision making during critical situation? Yes, of course. I mean, this is a very interesting question. If you allow me, my tomorrow's talk will exclusively talk about these things. It's not only the ethical dilemma, but there are certain issues. Let me just share my screen. Okay, there are issues related to safety. There are issues related to liability, privacy, cybersecurity, industry influence, and so on. So when you talk about safety and all, I'll try to cover all these very interesting questions related to ethical dilemma. You might be aware of the trolley problem as well, I think, because you've asked me a question related to ethical dilemma. So yes, there is a ethical dilemma associated, but let me give you some nice examples to define this. Okay, it will take at least 10 minutes for me to explain you that. So yes, it's difficult, but let's discuss tomorrow all these issues. Okay, how exactly we are taking care of it. Okay.
Okay, sir. Thank you, sir. I'll let them ask. Okay. So with this, let me conclude. Yes, sir.
Please go ahead.
Yes. With this, let me conclude the session 1. And we thank Dr. Digvijay S. Pawar, sir, for his valuable time. And the insights you have shared was fantastic, sir. And we are very much excited that we are going to be in another session with you. And thank you for the information you have shared till now. And we are very excited. And thank you for joining us for this time, sir. And let me tell you the participants. The feedback link is in the chat box. You can click that on the chat box and you have to fill it. The link is not going to be standing for longer time. So kindly request to fill the form as soon as possible. And with this, let me conclude session 1. And on all behalf of Basis of Technology and Sciences, and on the behalf of all the participants, we thank Dr. Digvijay Pawar, sir, very, very much for